Welcome everybody to our talk about unstructured data and how to structure them. We are Christian and Stephanie from Munich, and we are specialized in text analytics. We usually perform text mining in all kinds of huge amounts of data, and today we are going to focus on openly available data. We are going to show you how you can take some really high-performing open source tools and put them together with just the right kinds of algorithms, and then get behind the dig into data and find out what kind of topics are hidden in data, unstructured data. So why the hell would you want to do anything like this, get unstructured data and dig into them? Fact is, you already know unstructured data is everywhere. You go into the internet, there is your own emails, there's blog posts, there's social media, everything unstructured. You go into your company, there is your customers' emails, your customers' phone calls, internal blog posts, and so on. So all kinds of unstructured data. And the thing with unstructured is, unstructured means hardly analyzable, unstructured data means hardly comparable. And if you want to make them comparable and analyzable, if you want to structure these data, this usually takes a lot of money, it's expensive. Everything big data. So what are we going to do today? We are showing you a method how you can take different kinds of sources, which are probably kind of the same, but they are unstructured, so you can't compare these sources. You don't know if they are the same content or not. We're going to show you a method how to get behind these structures of these sources, and also we're always taking a look at how can we do this in the most efficient way possible. So we're taking today two news sources, Al Jazeera and Reuters, and news categorizing. News is a really hot topic for many people nowadays. Many people want to get behind the, like, can I draw the line between real news and fake news? How the hell can I do this? And we are tackling now today a first step into this direction by taking these seemingly pretty different kinds of news sources and finding a way how to compare these two news sources. How do you do a challenge like this? What's your first step? Well, everybody who's seriously interested in text usually starts with visualizing it. So this is what we just did. On the left-hand side, you see a word cloud from the last 9 years of Reuters World News. It's about 170,000 headlines. On the right, you see a word cloud of the last 9 years of Al Jazeera. It's a little bit less, about 100,000 headlines. And what's striking about this is, if I hadn't told you the left is Reuters, the right is Al Jazeera, from the very high-level topics, you wouldn't be able to tell a difference. First interesting point of insight. But can this really be true? Are Reuters and Al Jazeera really always talking about the same stuff? Our intuition tells us probably that's not so. So let's leave this high level and get into the data. Let's dig into the data. How do we do this? We are going to start with something which is already there. Luckily, Reuters and Al Jazeera already has a scheme of categorizing their data. On the left, you see the categorization scheme of Reuters. And what's already interesting is that if you compare Reuters and Al Jazeera, you remember the word clouds. We thought probably maybe they're just copying from each other. It looks pretty much the same. The categorization scheme already tells some different worldviews. Reuters is very much topic driven. You have markets, you have technology, you have business. While on the right, Al Jazeera has chosen another way of putting the news into a structured scheme. It's much more geo-focused. You have Middle East, Americas, Europe, Pacific, Africa, Asia. So interesting. What are we going to do now? You remember we want to make these two news sources comparable. So we have to decide on a categorization scheme which fits to them both. We decided that we want to go for the 6 geolocations of Al Jazeera and some of the Reuters topics. Technology, business, maybe some more. We're going to take them, apply them to both the Reuters news and the Al Jazeera news, and then we are going to see what's the result of this. So, in other words, what do we want to do? And this is a thing you can, of course, also transfer to other kinds of data. We have found some useful categories, and we want to transfer them from one source to the other. On our first step, we have the Al Jazeera geolocalized categories, the 6 ones, and we want to apply these ones to the Reuters texts. In the second steps, we are going to use the Reuters topics, and we are going to classify the Al Jazeera text with the logic behind these Reuters topics. So let's start with the first challenge for us. We take the Al Jazeera geolocalized. I'm going to figure out at the end of the talk how to spell this. The Al Jazeera geolocalized categories, and we apply them to the Reuters logic. So that sounds already pretty easy. Geolocalization. I think we could start with a deterministic approach and leave the stuff with machine learning maybe for a little later. So what have we done? We took a look at the 6 geo-localized categorizations of Al Jazeera and wanted to figure out if there are category-specific keywords. And we are lucky, there are really category-specific keywords. And before I turn to the next slide and tell you what the category-specific keywords are, we defined category-specific as a word whose turning out in one, occurring in one category 90% of its time. So surprise, there are really category-specific keywords for the Al Jazeera categories. For example, if you take a look at the category America from Al Jazeera, the word Castro or Guantanamo, if you have a news who contains one of these words, you are pretty sure it belongs to the category America. If you have some news which contain Nepal or Kasai, you are pretty sure it belongs into the category Asia. Interesting. But don't be too naive when you want to apply the category-specific keyword approach. We have one example for you. York. York should never be anything, you shouldn't apply York to your category-specific keyword approach, because York could just be a conference in York, which should be category Europe. But if you have a news headline like President Trump's apartment in New York, you shouldn't relocate the President Trump's apartment from America to York in Europe. So you should just have to pay attention to not mix these words up into your deterministic approach. We are not taking words like York into our deterministic approach, but we have the words you see here. And we are going to apply these words, this deterministic approach we derived from the Al Jazeera categories, now to the Reuters categories. So what's happening there? Okay, so first you have the, this is not the result, this is at first you see here the distribution of the news of Al Jazeera within their original categories. And you see Al Jazeera is pretty much focused on the Middle East and everything else is more or less the same. So now we apply the logic behind these categories onto the Reuters news and see how many documents turn out to be in the different categories. That's interesting. Reuters talks about the Middle East pretty much the same like Al Jazeera and has a much more strong focus on Europe than Al Jazeera. And these right lines you see for the first times, these are error bars. Always when you apply deterministic or machine learning approaches, when you do classified data, you have an error rate. We are going to get back to this later. Just to let you know right now, there's probably some errors in our calculation right now. So wouldn't it be interesting to compare the deterministic result we were talking about for the last 5 hours, 5 minutes? Feels like 5 hours for me, deterministic. With another approach, the machine learning approach. We also did this. So that's the result from the machine learning approach, and I'm going to skip back to the deterministic, the machine learning. And what's interesting is, overall, the two approaches, they don't really differ from each other so much. It's pretty much the same. Okay, so what have we done just now? You just got to know a scheme, how to deterministically categorize data. How do you do this? First, you find some rules for deterministic classification. We were lucky because in Al Jazeera, we already have pre-categorized a pre-categorized data set. We took this, we separated from them the category-specific keywords. Then we applied these keywords to a new data source, to Reuters. We saw what the results are. Are they good? Are they done correctly? What is the error rate? If you are already satisfied with your first result, great. Probably you're not satisfied and you're going to iterate a lot of times. By this, we classified Reuters news with the geo categories from Al Jazeera. Okay, check, we've already done this. So let's continue our journey. Remember, what do we want to do with all these things? We want to make the Reuters news with the comparable with the Al Jazeera news. Right now, they have been unstructured. This is a first approach to structure these two data sources. So we've done already this. Now we have the Reuters topic and we want to apply them to the Al Jazeera unstructured texts. How do we do this? First, we again start with visualizing the two topics we are most interested in. On the right-hand side, you see the category business from Reuters. And that's interesting because, I mean, who would have guessed that Greece and Euro analysis, bailout should be significant for category business? You probably already get a feeling maybe they are not category-specific words. On the left-hand side, you see the Reuters category technology. You have words like Facebook, Apple, Google, USA, iPhone. Maybe there could be some category-specific keywords in them, but who knows? Let's see what the data are telling. And we have analyzed if there are, again, category-specific keywords in the topics technology and business. And again, category-specific means if a word appears 90% of its time in one category, we say it's category-specific. We checked the category business, and there's not one category-specific word in the Reuters category business. What about technology? Technology is a little bit better. There are some category-specific keywords, but we want to classify a really big amount of texts, and we of course tried it out before. These keywords are just not enough to get a proper example for us. So now is the time to leave the deterministic approach and go to machine learning. Our learning is if the context is crucial, or if the text structure is a little bit more complex, often you just need to leave the deterministic approach and apply something like machine learning. We did apply machine learning. Here again, you can see the data we started with. It's some more categories we have from the Reuters database. We have the categories US, politics, top news, business news, markets, and technology. And you can already see, okay, Reuters really puts a lot of things into US, into politics, and the other ones a little bit less.
But the world has been omitted here because Reuters puts everything in world, and Al Jazeera would, of course, everything would fit into world. That's why it's omitted here.
Yeah. So you already see you can't just take categories from someone else. Probably they're not going to fit our needs, so we just left world. And now let's compare these pre-categorized data from Reuters with the results our ML algorithm achieved. So what did we do? We gave the ML algorithm these pre-categorized data from Reuters, let it train on it, and then gave the ML algorithm the not classified data from Al Jazeera. So what's the result from Al Jazeera? You see it's less. I hope you can see it, it's the right thing. Al Jazeera didn't succeed in classifying so many news like Reuters, but nevertheless, we were able to find at least some news for each category. But what's kind of troubling, if you see top news and just compare the highness of the error, indicated errors, I wouldn't go with top news probably if I had to trust the results. Business is better, technology is also better. So what have we achieved so far? We now applied the ML. You're going to learn what applied the ML means in a bit. And by doing this, we followed this process. We found a source with interesting topics. We really like the Reuters topics, for example, business and technology. Then we extracted these topics and gave them to the machine learning algorithm, let the machine learning algorithm train on these pre-categorized data from Reuters. Then the trained machine learning algorithm classified the not yet classified Al Jazeera news. And then we saw, is the result good? Where do I need to improve? How many times do I iterate until I say, yeah, okay, that's a result I can trust. What I think everybody now really is interested to know is, it seemed so easy, apply the ML, train the ML, and then it's done. How does this really work? And is it possible to measure the ML? This is where Christian is going to take over.
So a lot of people are talking about machine learning, but machine learning is just something which is basically really boring. It's linear algebra, so it's nothing more. It's just linear algebra with very large matrices, and that's why it's also very popular in the big data community, because it's very easy to handle these large matrices. So machine learning for text or for text classification is a bit more complicated, because linear algebra is something with numbers, text is not numbers, so we need to find a schema how to extract numbers from text, or how, a mapping between text and numbers. So we need a model for the text. There are actually different models how you can convert text to numbers. The most simple model is probably the so-called bag of words model. So you just count all the words which you have in all your documents. So you enumerate the words, and for each document you just say this word occurs 7 times, occurs 2 times, occurs not a single time. So you convert each of these documents to vectors, and vectors is something which is very popular among the linear algebra folks here, so you're on a good way to do this. But unfortunately, that does not work out perfectly. Why? It's too simple, because you have very long documents, and in very long documents, obviously, the probability that you have a specific word within the document is much higher, because the document is longer. So in the first step, you don't count the number of words, but the frequency of words. That means the relative amount of words in the documents. That's called term frequency. And that also turns out not to be perfectly suited because you have some words which occur in every document. So they are not specific for any document. So you try to normalize that with the occurrence of the words in all the documents. And that's called inverted document frequency. So the best method, or the supposedly best method, is to convert all of this text into a document term matrix where you use this term frequency and inverted document frequency. Fortunately, there is already software available which does that, so we don't need to invent that, and that software is also possible to run on clusters, so you can do that with really huge amounts of text. There are different machine learning modules or methods available, like support vector machines, neural networks, random forest decision trees, or even naive Bayes. So normally with text analytics, it works best to use the support vector machines. Let's take a look at the support vector machine. How does it actually work? Let's assume that we have this two-dimensional points here, the gray points and the blue points, and you want to separate the gray points from the blue points, and they are separated with this wiggly line, which is very hard to, well, parameterize. So you do something which is quite trivial, so you do some kind of transformation. So the rectangular shape is then transformed to some very irregular shape, and the points are transformed with the same parameterization. And what happens is that, fortunately, now you have a much easier situation where the red line separates the gray dots from the blue dots. And this is something which is usually achieved during the training phase of this machine learning algorithm. So if we are now in the classification phase, we get new points. And the new points are then mapped to hopefully the correct side of the red line, but sometimes they are mapped to the wrong side of the line. And it's very illustrative in this graphics, but usually you don't see that. And to be sure that your results are really correct and that you're not trying to sit on this chair, because obviously it's not very stable, it makes a lot of sense to already take a look at some quantitative quality values during the training process, and also during the classification process, of course. And that's what we did, because otherwise we would not have this, these error bars. So we didn't cheat with these error bars, but we didn't tell you about the methodology which we used to get these error bars. So the error bars are true both for all kind of classification, for all kind of statistics, and so it's easier to explain that with deterministic classification. Let's assume that we have a lot of news articles with the topic Europe. And now we want to classify the news articles, so we say, well, France is a large part of Europe. So we have a lot of these news articles already classified because it's France in it. It's just an example. Of course, there are many more countries, but then it's very hard to explain. So you use other countries like Poland, you use countries like Spain, but there is still some red stuff here which is not yet been classified. And then you use Italian. Italian gets this red space down there. Tackling this red space up there is quite difficult because it's some kind of long tail, so you will have many, many countries. We skipped that, and we said, well, we will not match everything, we will just match a certain fraction, and that fraction is called the recall. Recall means how many of all articles do we find with our deterministic or with our algorithm. So it's just a fraction. The fraction here maybe is 90 or 95%, so it's quite a good fraction. But the Italian, which was used to match quite a lot of articles, also has some problems because we might also match some articles like more and more Italian restaurants in China. Obviously, that's not news from Europe, it's news from Asia. So it's something which we did wrong. And what we did wrong here is the so-called precision. That's true for all of these classification methods. It's not something which is specific to machine learning. You can also use it for deterministic classification, and you should. Because if you do not have these quantitative values, then you never know what the outcome of this will be. And the precision and recall were also used to calculate the error bars in the histograms. Precision goes down, recall goes up. So back to reality. Of course, in reality, that's at least what we have in our projects. Normally, we have customer-specific categories. That's not so trivial, because in the customer-specific categories, it's very hard to find pre-categorized text. Actually, it's even more complicated, because finding the suitable categories in some huge amount of text is difficult. It's something which you have to functionally discuss with customers, and you can use some strategy like topic modeling, but topic modeling is manual work. It's also quite computation intensive, so you need big data clusters in order, if you have really large amounts of text, to perform this topic modeling. Topic modeling gives you some ideas of what could be interesting topics, but it doesn't tell you, well, that's topic A and that's topic B. It just says you have a very high rate of co-occurring words, and then you are free to choose the name of the topic of these words or discard them and say, well, that's not actually a topic. But at least it's some strategy which we found useful. Then you have to verify the categories. If you found categories that, well, these are perfect categories, I have completely understood that, and you give them to your colleague and say, please classify 5 texts with these categories, and he or she comes out with a completely different categorization and says, well, that belongs to that category. Oh, no, then something is wrong with your categorization scheme. So it needs to be reproducible, because you can never train a machine learning algorithm to something which is not reproducible for you yourself. So if you are not sure whether to put it in that category or in that category, it will be very difficult to find a machine learning algorithm which will do that much better than you do. Maybe it will do it in a certain way, but that's not the way you expect it. And that's also manual work, so you have to check that. Afterwards, if it's possible, you should go ahead and try to find pre-categorized data. If you succeed, then you will save a lot of manual work, which you see on the right-hand side. Because if you do not succeed, then you have to manually classify the training set. And that's something which is strikingly expensive. So let's assume you want to classify 10,000 documents. Then you can, of course, do it on yourself. You can also hire some kind of crowd workers. Sounds inexpensive, but is not so inexpensive, because for 10,000 documents, you pay something like 5,000 euros. That's a lot of money, and that's not everything which you have to do. You have to perform some extensive quality assurance afterwards, to see whether these documents have been categorized correctly. And apart from that, the correct training set has an extremely high impact on the quality of your final results. So first choose the training set and then give it to some crowd workers, which then have to perform this manual work. Afterwards, you can train the machine learning algorithm, do the quality assurance and optimization. Usually you try different algorithms, do some kind of cross-folding, iterate and improve. But cross-folding, iterating and improving and trying different algorithms is also manual work. So it's not going on its own. It's called machine learning, but it's associated with a lot of manual work, which needs to be done. And in the final step, the classification, that's also only one step. That can, of course, be done by the computer or the big data cluster on its own. But unfortunately, even if you have classified all that data, you have to perform the manual quality assurance, which is, again, manual work. So lots of manual work involved in your machine learning project. I've already said that it's very important to choose the correct training set. Because that gives you an extremely high impact on your final results. So how would we do that? Let's come back to our text documents. Of course, you're free to select the documents with the highest word variability. So if you only choose documents which have a very limited word variability, you will have in the end a perfectly trained machine learning algorithm which will not know anything about the words in the complete document set which you want to classify afterwards. So you have to take a look at stop words, and you also should take a look at your distribution of the content, because you might have a long tail distribution, or you might have somehow dictionary-like distribution. That's a long tail distribution. But if you have an even distribution, a so-called dictionary distribution, that will be very hard to classify. You would never be able to classify a dictionary with machine learning, because the training set would have to be the whole dictionary, because otherwise you encounter unknown words all the time during your classification phase. It's a complicated problem, and it's very hard to solve. You need lots of computing power to solve that, and you will only be able to solve this approximately, but it's crucial for all following tasks. Let's suppose you have a good situation that you choose a training set which has certain words in it, and your complete data set which you want to classify has the same words. Then it's fantastic. Your machine learning algorithm, at least in theory, has the possibility of classifying all documents correctly. Unfortunately, the not so good situation arises if you have lots of unknown words in your complete data set which you want to classify. Then the machine learning algorithm can only guess to what category the documents might belong, and the error rate will be higher. It will even be higher than the one which you have measured in your training set. Intelligently choosing the training set is really complicated. Yeah? Because let's assume that you have 1.5 million documents and you choose a training set of 10,000 documents. The number of possibilities of choosing 10,000 documents out of these 1.5 million documents is overwhelmingly large. Even if I wanted to write the number on the slide, even if I only use the black pixel for each 0 in the number of possibilities, the screen would almost be black. So it's 10 to the 1.5 million power or something like that. Yeah? So it's really, really large. Yeah? Why is it, and how can we intelligently do that? Yeah? So we can choose a training set which creates the maximum word overlap with the complete data set. So we have some kind of quality measure. So it's the possibility of choosing the training set and then without performing all this machine learning stuff, already telling how good could the training set, at least in theory, be. There's even an improved approach that you really choose the training set in such a way that you find the minimum of the words which are contained in the training set, and build the intersection with all the words which are contained in the complete data set, and you try to minimize that. But that's also complicated, and if you have only parts of the data set available as a training set because the data is flowing in continuously, then you have to keep to the distribution of words and choose the words which are most frequently used now, because you assume that in the future they will also be most frequently used, and so you have the highest chances of really encountering documents where you know at least one word. Yeah? So you already need statistics in order to build a training set which will work in the end during your classification phase. The result is the optimized training set, which you can then try to manually classify and do manual quality assurance and stuff like that. But at least you have built a situation where, in theory, you have very high chances of getting good results from your classification.
So, summary, our learnings. You really, we and probably you also, you need to focus on cost efficiency of your classification results. How can you do this? You got many implications from the last 40 minutes. To wrap it up, you can get more pre-categorized data, look everywhere you can, get creative, dig into the internet. You can use NLP for even better semantic extraction and then train on the extracted features and improve the machine learning algorithm. You should not choose more documents than necessary for manual training set classification, because, like Christian stated many times, manual classification is so expensive. And also, really important thing is take the courage and admit, wow, okay, I've classified the best I can. Now I'm really in the long tail. What am I going to do with this long tail? This usually involves talking to the customer, and if you have a customer, and decide on, are we stopping now or do we need to raise the budget? When is it finished? And second thing is focus on high quality of your classification results. Just because you want to do it in a very efficient way doesn't mean you should cut back on quality of your results. Good parameters are the right training set for your machine learning algorithm, and you should evaluate different algorithms and then choose the best. And when you have the best algorithm, and the best algorithm means immer the best algorithm for your specific problem, you should choose to optimize this algorithm. These are our learnings. Thank you very much for listening and paying so close attention. We hope you get something interesting out of it. And if you want to continue talking, we are around and also available via email and social media. Do we have time for questions, or is it 5 minutes? Okay.
How did you find York? Was that a manual search, or is that an automatic way to find these words that screw up the category?
So it was not in the definition of the category-specific keywords, because there we said, okay, only if it appears 90% of the times in one category. It was really manual work. I can't remember, maybe we saw it in a word cloud. This is really good, why we like visualizing the text. And we have the system that you visualize it on a very high level, and then you can dig deeper into the layers. And somewhere on this process, we thought, wow, York is a perfect example you should never use as a deterministic classification scheme.
And what about multiple categories? Because I imagine not every text fits perfectly
Yes.
in one category.
Yeah.
How did you handle that?
Well, actually, that's a very good question, because then it's not a single label classification problem, but a multi-label classification problem. Yeah, and there are also algorithms for multi-label classification. Yeah, actually, we could use multi-label classification. It could also be a good idea, because the categories are so orthogonal. Yeah, so some news from Al Jazeera, which is clear because it's something about Middle East, could be world news and technology news in Reuters. You could do that. Yeah. Of course, yeah, we also tried that, yeah, but it was quite specific, so we didn't find many news which fit into different categories. That just did not happen with that data set, but of course you are right, that should be checked. And also still coming back to this York problem, the interesting fact is that New York, of course, would be unique, yeah, because New York is something which is specific for the United States or for the Americas, at least most of the time. Yeah. But what we didn't tackle in this iteration is multi-words. Yeah. You could also do a multi-word deterministic classification. Yeah. But if you have something like 80,000 words or 100,000 words, yeah, then it's you can check each, but we used facets and stuff like that, so it's a bit easier. Yeah, but even for this multi-word, the computational effort is much higher to find possible candidates and also check that against the data set. But it's possible. Yeah, so we could have eliminated this problem. Yeah, and you can also do it the other way around and say York is always Europe if it's not New York. That also works in the negative sense.
How much pre-processing of the text did you do? Did you use part-of-speech labeling to start?
In a real project, we would do that, yeah? But here this is some kind of sandbox project which we used because we just wanted to learn and we wanted to use something which can be presented openly. So we used almost no pre-processing. So we eliminated some words, had some problems with well, different locales and stuff like that. But then all work was just delegated to the tokenization and document frequency, term frequency, inverted document frequency. Yeah. So I think we have to stop. Yeah.
Okay, you can come around. Thank you.